Okay, so I'm going to be doing problem number 43 in the chapter 7 homework. So this is the problem. I can pause here to read that. And so I can start by writing down the given. So the mass is 5 kilograms. The force in the x direction is 2x plus 4 newtons. And x initial is 1 meter, x final is 5 meters. And then so for the first part of the question, it asks you the work done by the force on the particle. So work equals question mark. And then so you can start out by writing work equals the integral of force dx, and then plug stuff in. So the initial x is 1 and the final x is 5. And then you plug in the 2x plus 4 dx. And then, so since you're finding the antiderivative of this, then you go x squared plus 4x and the 1, 5. And so yeah, this is the antiderivative of that. This is antiderivative of that. So because if you find the derivative of these, you would get that. And then then you would plug stuff in, so you do final minus initial. So final, so you'd get 25 plus 20. Plug 5 into these two, and then minus initial, so 1 plus 4. If you do the math, then you get 40 joules. And then for the second part of the question, it asks you the change in the potential energy of the system. So change in kinetic energy plus change in potential energy equals 0. And this is because, so for part A, you found the change in the kinetic energy because the particle is moving, and then so that would be the work, which I put here. And then so since energy is conserved, it has to all equal to 0. So you plug in 40 joules for change in kinetic energy plus change in potential energy equals 0. And then, so change in potential energy would equal negative 40 joules. And then for the last part of the question, it asks you the kinetic energy the particle has at x equals 5 meters if its speed is 3 meters per second at x equals 1 meter. And then, okay, so you would do change in kinetic energy equals work. And so that would equal change in kinetic energy equals kinetic energy final minus kinetic energy initial. And that's the one you're trying to find. And so you do 40 joules from that problem over here, just plugging it over here, equals kinetic energy final minus 1/2 m from the, it's because you give it 2, so it's 5 kilograms. V, and they also give that to you, which is 3 meters per second squared. And then if you do the math there, kinetic energy final is 62.5 joules. And the reason why you find kinetic energy final is because you're trying to find it when x is 5 meters, which is the final position. And kinetic energy initial is this because x is at 1 meter, which is the initial position. And so